because we're going to be here at exactly that time.
All right, guys, I have a question already. It's in section 2.7.
Yes.
What are you doing? It's not my way, all right.
I know. I was trying to actually.
Yeah, it is. So no. Okay. So 2.7. Which one was it you're looking at specifically?
45 would work, but basically anything that has like, you have to be inverse any fraction with an x on top and x on bottom. It's like x plus anything, x minus anything. I just get stuck once I put the y and the x on the other side.
X on top and an X on the bottom.
It's not a number. This is my own invention. So, guys, there's a couple of homework problems that are like this. They have x in a couple different places. Somebody help me out.
Y equals
It's been a while. So, what's the first step?
Y equals to
Yeah,
X.
bring the y back in.
And then switch the Y and the X.
Which y and x?
Solve.
And the reason I put a little dotted line there real quick is because from this step to this step, I did not apply algebra. I applied a concept. So just, to me personally, it makes it clear that I didn't actually do something algebraically there. There's nothing in algebra that suddenly says, and now you switch the x and y. That's a concept of what I'm doing. How important is that? Not really. Let's just explain to you why I do that. And then what do?
Solve.
And this is where people freak out. I mean, you guys should probably be able to do this, and maybe you freak out right at the beginning, or you freak out right here. Whenever I'm trying to solve for something and it's in more than one place, I get all of them on one side, and then see what I can do. That's pretty much since the beginning of algebra. You get your x's on one side, numbers on the other. Here I'm going to get my y's all on one side. And the first problem, before I even worry about that, is part of what I want is on the bottom, so the first thing I want to do, multiply it up. Get a nice and straight linear, no rational part to it anymore. So multiply by y plus 5. So you get x times y plus 5. Equals 3y minus 2. Now, where are your parts that have y in it? Well, the one problem with that question is I haven't got all my parts teased out yet.
Take the 5.
Which side has not been, what kind of verb can I make out? Partalized, I don't know. This side, right?
X times Y.
So if I multiply this through, then I can see all my parts. Now, it's just like when you first learn algebra, you get all this stuff with y in it on one side and all the other stuff on the other side. And you can be kind of smart about it. Or not. It's your choice. Me, I always try, I would add 2 and bring the xy over so I don't get a bunch of negatives on one side. How important is that? Not really. I don't know if you guys even see what I'm saying. But I'd rather get all my y's over there, add the 2, subtract the xy. And let me just stop right there. You guys with me? I'm trying to solve for y. So how do I solve for a variable? I get them all on one side and get all the other stuff on the other side. That's just one-step generalization of what you guys have known since you first started learning algebra. Get all the x's on one side, all the numbers on the other side. Well, generalize that. Get your variable stuff on one side, get everything else on the other side. Same idea. Now, there aren't really two y's. Right? This is not the matrix. There is a spoon. But there aren't two y's up there. Right? And this is where you start to wonder about my sanity, if you haven't already. Why are there not two y's? Because what can I do?
Common.
Take it out. I've only got one y that was distributed to a 3 and an x. And then you solve for y by dividing by the stuff you don't want. Which means to do it.
Divide it by the 3 minus X.
Yeah, I don't want the 3 minus x, so I divide by the 3 minus x.
So that's the inverse.
That would be the inverse, yes. now let me point something. Is everybody semi-cool with that? Do you guys get that idea? That's how you attack anything like that, a ratio, and they got a couple x's. That's how you do it. Now let me talk about some side stuff going on here. Somebody help me out. The original function, what was the domain?
So
in positive infinity.
Let's say all reals except
0. Oh, it's negative 5.
Can I spell except negative 5, right?
Uh-huh.
That would make the whole thing undefined, so it would freak out. Everything else is fine. How do you know the range? That was easy. Figure out the domain was relatively easy because I can see exactly what x makes it undefined. Now I submit to you that we've just figured out the way to get the range just as easily. If I would have done this whole process, but I would not have switched the x and y, stay with me now. If I would have done this whole process, but I didn't switch the x and y, I just took this and solved for x. You guys with me? If I would have just taken this and solved for x, wouldn't the math have been essentially the same here? Right? So what would I have gotten at the end? I would have gotten x equals 5y plus 2 over 3 minus y. Now the really cool thing here is, what's the range? What can y not be? Y can't be 3. So the range is all reals except 3. Can't be 3. You guys semi with me so far? I can't remember if there was a question like that in the book now off the top of my head where they ask you for a range of this kind of thing, but that's how you can find it. And another quick, so the range would be all reals except 3. Let me see if I can tie this together a little bit. This is a bit of a preview. If I let x get really, really big, how important are minus 2 and plus 5? Can we let x be a trillion?
They're not important.
Not important. I got $1 trillion, I drop a couple bucks. I'm not going to be as worried as I would be like today. I'd be scrambling for this couple bucks. So those don't matter worth crap. So when x gets really big, this function looks like 3. You semi with me? And this is going to be the situation where if you graph this in your graphing calculator, you'll get something where it's approaching, I'm not sure exactly how it's going to be doing it, it's approaching that 3 line. It never gets there. And that's why the range does not include 3. This is in our future, what I just did. But I want to kind of give you a little preview. That's in the future. So how much you have to know for this problem? There. This other stuff is just me trying to make some connections. Okay. So if you have not tried to graph that in a graphic calculator, you should try it. See if you get something that's shaped sort of like that. Okay. All right. Any other questions for me to overanalyze? Anything else in the homework?
Not in that section.
Yeah. Oh yeah.
That's a pretty good grade.
I think all the things I got to do. There's been so much shit. Technically, some of it you just done.
Okay. This is an incredibly funky problem until you get used to what this really means, how to translate this into something you're more familiar with. So G inverse of 5, what is it? What's the answer really going to be? I mean, don't tell me the number answer, but what is it going to represent related to this guy?
Find the inverse and plug in 5.
If I first find the inverse and plug in 5, I could do it that way. There's another way that's much simpler, actually.
Just use 5.
If I'm looking for the input of the inverse to be 5, that means that the output of this must be 5. I mean, that's the whole idea here, right? The input of the inverse is the output of the original function. You with me? That's the whole idea of inverse functions. So it's really, this means solve just to really get you interested here, or I don't know if that's the right way to say that, but I don't know what that is, but I know it's going to be the input for the first guy, right? You guys good so far? The output of G inverse would be an X value, because the input of G is an X value. They are inverses of each other, hence the name. If I take G of both sides, what's going to happen? Cancel. So don't I get G of X equals 5? So that statement, find G of inverse of 5, it equals X, is the same as this statement, find X where G of X is 5. It's the same thing. And very often we'll see that. We'll see them, we're learning new stuff, we're learning new terminology, we're learning new symbols. Once the first step is translate what the hell they're asking me into something I know how to do. So we're learning that translation as we go along. So how the hell do I solve that?
0 equals x squared plus 4x.
Yeah, what is G of X?
25.
G of X is X squared plus 4X.
25.
No, careful. This does not say G of 5 anywhere. Right? It says where does G of X equal 5? There's G of X equal 5. Now just solve that. Now you're back in Math 90.
X squared plus 4x.
Right? And really, that's what most math courses do. The first 2 or 3 or 4 steps are Math 180, 176, and then all of a sudden you're back in Math 90. How do you solve that?
Subtract 5 and 0
Yeah,
down.
subtract 5. Can you factor that?
Positive 5 negative.
Good. Bigger one's positive to make the middle term positive.
But then you have to check them.
So X equals, yeah, we'll get there.
Negative 5 and 1.
Looking back here, what's the answer?
1.
1 is the answer. Good. And why do you think they had to say this?
So you knew which one they wanted.
The restrictions.
One-to-one function.
When would this exist? If it was a one-to-one function, right? Without that restriction, it doesn't pass a horizontal line test. With that restriction now, it's just 1/2 of that parabola. Sorry. So then I'm allowed to do this. You're always going to have to see a restriction like that or put one on there if you're trying to talk about inverses of parabolas or any even-powered functions. Any even-powered function like that's going to have some curling back on itself somewhere. It's not going to work. All right. Is that decent? So in general, if I see like find H inverse of 3, I can translate that as solve this equation. That's one thing to take away from it. That actually captures a lot of ideas of what inverses are all about. As you learn what the hell these things are about, you learn how to translate from what they ask you to the math you know how to do. That's the idea. Okay. Okay. So that's a good question. Any other questions? Oh, okay. So we'll get into that. I don't think we've officially really... I think I just really quickly said something about Chapter 3. I haven't actually stepped into it yet. So hold on to that. All right. So not seeing any further questions, we're going to get into Chapter 3. So I've said this before when we start talking about transformations. You've got your, what I consider your base parabola, your base quadratic function. Where's its vertex?
0,
0, 0. 11. Okay, that's exciting. Now, we know how to take that, pick it up, and move it around. So somebody help me out. If I want a vertex to be at -7, 4.
Plus 7 minus 4.
What does it
Plus
have?
4. Plus 7 plus 4.
Plus 7.
So your y equals
X
X
plus 7 squared.
X squared plus 7.
Plus 4.
plus 4.
I love it.
That's X
You
squared.
guys with me? Don't forget, when it's in with the variable, it actually looks the opposite of what it does. Because all my inputs now can be 7 smaller than they used to be, because the first thing I do is add 7. That's why it's down 7 from where it used to be. Cool. Side. So in general, what's this general form? In fact, from here I could, if I wanted to, I want it to rise twice as quickly. I could throw a 2 on there. Put whatever number I want there, make it skinny or fat, right? Something less than 1, 1/2, 1/3 some fraction would make it fat. Poor little dude. His slope would be smaller. Okay. So in general, our standard form. You have to take my word for it. That's what that said. Standard form would be y equals a times x minus h squared plus k. It's very similar to, mx plus b. Of course, it's very, very, very similar to x minus h squared plus y minus k squared equals r squared. Circles. Right? If we know the standard form of these, then algebraically, if I put them in that form, I can tell a lot about the shape. So if I put it in that form, I know where the vertex is. And that's the most important point on a problem. Okay, that's exciting. So your quest is going to be try to stomach what you have to do to put it in that form sometimes. So let me just give you kind of an ugly example. Oh, let's see. Oh, yeah. Now, to put it in that form, what basic procedure must I use?
X
Do it one more time. Completing a square. Thank you. That might be what you said. I just couldn't hear. What is it? Anybody realize what it is about completing the square that it can't handle that's currently here?
7. And the negative
The negative
5.
5. It can't handle it unless it's a 1 coefficient. So the very first thing I have to do is take a negative 5 out. Now, in that respect, I didn't make this as ugly as I could have. But I didn't want to quite go whole hog yet. So if I take a negative 5 out, and I'm only going to take it out of this piece, because the numbers are I can leave the numbers out. There's a place for them. Right? Don't need to do all that. What's left inside, of course?
X squared plus 5x.
Careful. Careful.
Oh, you have to take the x out too.
That's right. Leave yourself a little room. Okay. So we actually haven't done a damn thing.
Minus 5x.
We just changed the way it looked. And now we're going to continue to change the way it looks. In fact, we're going to do a lot, but we're actually not going to do anything. We're just going to make it look different. If I can make it look different and put it in this shape, I know where the vertex is, which is the most important point on the problem. Yes?
I think is there a way where we can find the vertex with minus negative?
There is, it's
2b
coming.
over a.
Something like that. Yeah, that's it. It's coming. So how do I complete the square for this guy? What's the 2 steps?
Take
Yeah, so completing the square. Step 1,
Take
half of the middle dude, so negative 5 over 2. Step 2,
square.
square. 11. 25 over 4. So what's got to go here?
25.
25 over 4. If I put plus 25 over 4, now here's the part, let me do this in,
Times by negative
here's the part that people really, really, really love to hate. I did not just add 25 over 4.
No, it's times
I did
negative
not.
5.
I
times by negative 5.
I subtracted 5 times that just now. That's what I just did. So real quick, stay with me. You have 2x plus 3, right? And I put in there a plus 1 with the x. Did I actually just add 1 to it? Hell no, I did not. I added 2. Why can you not see it? Because the 2 is out here, but that's 2. I wouldn't put plus 4. I didn't add 1. I added 2. What does this actually become? 2x plus 2 plus 3, 2x plus 5. Did I not just add 2? Yes, I did. Cool. So whatever I put in there, what is it really? That times that. Of course, we know that. It's just so hard to remember that. We just wrote down 25 over 4, Jeff. What the freak? I know I just put 25 over 4. Why don't I just put minus 25 over 4? But I didn't. Because it's not what you did. You did negative 5 times that. You guys with me? Really? So in general, when you're doing completing the square, you have got to take into account what the coefficient is. We're so used to seeing it to be a 1 for some of these basic completed square problems that we forget in general you got to take it into account. 1 is easy to take into account. It says it stays the same. So what do I actually put out here then? I just subtracted 125 over 4. Is that cool? That's what I just did. So what do I have to do out here? Add 125 over 4. Now, if you still don't believe me, if you distribute this, you get that, and negative 125 over 4, which that kills, thankfully. So overall, we've done nothing. Whatever I do, I must undo on the same side, so I'm not doing anything, right? The old Indiana Jones thing. Of course, he messed up a little bit. A few grains too few, or something. You guys love it. So now where are we at? We're at negative 5. How do you factor this? The awesome thing about this is that first step tells you how it's going to factor.
Minus 5 halves.
What do I get out there?
97 fourths.
Minus, 28 over 4 plus 125 is 97 over 4. Negative, positive, sorry. Of course, there I just got like denominators, right? Okay. So where's this guy's vertex? This extremely ugly parabola. Where's his vertex?
5 halves, 97.
5 halves, 97 over 4.
Yeah. Once you get there, it's easy. It's getting there. That's the hard part. But, you know, I desperately want you to understand it. Let's take an easier example real quick. And if I have this, so that came from here. I don't have any number here, do I?
No.
So whatever I do here, the numbers better cancel. So what do I have to put here?
6. So 9. Wait, 6 divided by 2 is 3 times 9.
Plus 9.
Yeah,
Plus
plus
9.
9, because half of 6 is 3, squared is 9.
But 9 negative.
If I just do this,
That's not going to.
here I got 27 minus 9. And where the hell did the 18 magically come in from? I needed to cancel.
Yeah.
So I just added 9 times 3, so I better subtract 9 times 3. I better subtract 27. Okay, so that's really what we just did over there, just with the slightly uglier numbers. So, yes, ma'am?
And the reason why you do the opposite is just...
It's all on one side, so
Right.
if I add something to one piece, I better subtract somewhere else. So overall, I didn't do anything. Because this would be equal to h of x. So this better still be equal to h of x. So if I add 27 somewhere, I better subtract 27 somewhere else. So that overall it's the same thing.
Right.
We're used to doing this.
Adding it on both sides.
But don't be doing that. Most of your upper level math teacher will go, what the hell is that shit? No.
Well, could you do that just to remind people?
Sure, you can do that on the side, then erase it.
Okay.
Yeah, I can't tell what that was if you erase it. But I'm not nearly as anal as some of the, and you have to be a little anal the further you get in math, and I understand that, but there really is nothing necessarily wrong with putting it there, but I know enough future math teachers will be upset unless you take me. So just got to get used to dealing with it all on one side. And that skill is important for future things that you have to do also. Just balancing things out on one side. Okay, is that cool? So of course this would become, and the vertex of -3, -27. Skinny. Cool. All right, so now we have, let's kind of go through what we know. We know a line is mx plus b, and y minus y1 crap. Let's just stick with this. We have a circle is x minus h squared plus y minus k squared plus r squared. Remember that stuff? HK would be the center. I like it. Cool. And then we have for a parabola. Where this is the vertex. Yay. Now, that is disgusting. I don't want to do that when I don't need to. So if they ask me, if I need to put it in standard form, that's the procedure I have to take. If they just want me to find the vertex, screw that. Let's figure out a shortcut. That's a lot of mess to go through. What was completing the square? There's a shortcut for that. Because very often I use completing the square to solve something. What do we use instead now? That's a shortcut of completing the square. Quadratic formula, I love it. Quadratic formula is a shortcut of completing the square. So there's got to be probably a shortcut that's based on the quadratic formula somehow for this. Right? And you just hang out. I know. Just hang out. So let's look at the quadratic formula. Let's write it a certain way. So let me write this a little bit different, please. All right. I was excited. And that's related to a big mistake I always see my students do when they first learn this is they break it up without putting that over 2a also. But that's how it is, right? If you break that up. All right, that's great, Jeff. Now keep that in mind. Store that. Now. That's horrible. My scale is so bad. Horrible. I'm obviously trying to force this to be so I can't. That's even worse. So let's say we have a parabola whose intercepts are -1 and 3. Where must its vertex be? What must the x part of the vertex, what must that be? Because what's the interesting thing about parabolas as far as finding the vertex? If I know points on either side, where's the vertex got to be? Right in the middle, because of the symmetry, right?
No.
So -1 and 3, what x value is right in the middle? 1. Right, if I average those, 3 minus 1 is 2 divided by 2 is 1. I get 1 right in the middle. So the vertex, pretend like it's there. Right, that's where it will be. And then how do I find the other piece? So the vertex has got is a point. I would just plug it in whatever function they gave. Okay. So let's do a concrete example, and then I'll show you how it relates to this thing. What are the x-intercepts of this guy here? 4, -7. So what's right in the middle of those?
11 halves.
-1.5. Cool. So the vertex must be somewhere on this line, right? Going through negative 1.5. So of course now, how do I find out where the other piece? So I know the vertex is negative 1.5 something.
Oh, you have to
How would I find that something?
plug it in.
Plug it in. So you get negative 5.5 times 5.5, whatever the hell that is. Somebody help me out. What do you get when you plug a negative 1.5 in here? Just do 5.5 times 5.5. 30.25. And it'll be negative. Which makes sense because it's got to open up. Right? It's positive out here, so it's got to open up. It's got to go through there. And it's a negative 30.25, and it opens up from there. How do you guys feel about that? So the basic concept I'm trying to get you to understand is that I know 2 points that are across from each other, and of course the most common ones we know are the intercepts, because those are relatively easy to find most of the time. Then the vertex must be right in between the two. Now, if I wasn't able to factor something, what would I have to use? Quadratic formula, right? And this gives me the two, in general, it gives me two x-intercepts. So this would be negative b over 2a minus this stuff. This would be negative b over 2a plus this stuff. And of course, what's right in the middle of those two? It's almost too easy of a question. It's negative b over 2a. Because if I take negative b over 2a, add something, and negative b over 2a minus the same thing, what's right in the middle? Negative b over 2a. It's the guy that you're adding, subtracting. So he's right in the middle. It's defined to be right in the middle. So where must the vertex be then?
At negative b over 2a.
At negative b over 2a. So I finally caught up to you. So thank you for being patient. So the vertex for f of x equal to ax squared plus bx plus c is located at negative b over 2a. That's the x piece. How do I find the y piece?
Plug it in.
Plug it in. So f of negative b over 2a. And they can actually plug it in and simplify it and get an expression. Well, who the hell cares? Whatever number negative b over 2a is, just plug it into f. You can take the whole idea of finding patterns a little too far sometimes. Right? I think the book, can't remember if this book does it. No, this book doesn't do it. I like you. But some books actually take that out and figure out an expression for the who cares. Just plug the number in. So, specifically, what was that one we just did? Negative 5x squared plus 25x minus 7. Was that the one we just did?
Yeah.
Yep.
Okay. So where's the vertex? Using the shortcut.
Maybe do
X equals negative
20.
25 over 2 times a. So negative b over twice a. Cool. So I get 25 over 10, which reduces to 5 over 2. Is that what we got?
Yeah.
Thank God. That was a lot quicker. Damn. Last time I had to complete the square, put it in standard form, and if all I want is the vertexes, that's the only thing I need, then I'm not going to complete the square. That's too much work for that shit. This is a nice, quick way to get the vertex. So I get 5 halves, and so I know half of the vertex. To get the other part, I have to plug it in. Negative 5 times 5 halves squared, plus 25 times 5 halves, minus 7. Yes, ma'am.
Wouldn't it be negative 5 over 2? Because it's negative b over 2a?
Yeah, but the negatives cancel. Because a itself is negative. Minus what? These are negative b over twice a. I think it was it plus there before? Please don't tell me it was minus. It was plus, okay.
So we get the, when we complete the square, we had negative 5 over 2 squared. So that was how we completed it. 5 over 2 is still negative.
No, but yeah, I know. It was this way, right?
Something, yeah.
So then the vertex would have been at 5 halves. Because the net is do the opposite of what it says in there, remember? Yeah, good. Thank you, though.
Is it
Yes.
because the standard form is a minus something, h or something?
Yeah, it's ax minus h squared So if there's a minus 5/2 in there, h itself is actually 5/2. So if you like looking at it like that, cool. Some people don't understand that at all, that the minus is a part of the form, so it's not going to be a part of the answer. So if my parabola was in the form x plus 4 squared, h must be negative 4 to make that minus become a plus. So h must be negative 4. So you can remember it as part of just the form, if you want to. Okay. The reason they did that was because of the fact that when you transform it, it's the opposite of what it looks like, and that leads to writing like this. But you can think of it the other way around. That'll work. So that's awesome. That kicks so much ass because we're heading into our another round of pre-calculus word problems. I know. It's awesome. No. Well, I love that question because the application of mathematics in real life is word problems. It's just that we don't see it that way because there's nobody to sit there and write our problem down necessarily, following us around. I got a problem. Write this down. Let me see it. It's a word problem. No, but in real life we got a problem. You can describe it to somebody. You've got to figure out what to put where. It's the same thing. So let's take a second and look at one of these word problems. And the horrible thing really about this section is they kind of set the problem up for you. And of course, from your perspective, that's a good thing. But from your perspective, it's also bad because on my test, I'm going to have you set your own problems up. Let's see. Look at number 69. That's kind of interesting. This is page 231.
They did the work for us.
Somebody in here at all related or working in the farming industry or planting crops? Or I've never actually checked to see if they actually use models like this. I'm sure they do. It's probably built into some farming software.
They use it at
It's the new simulator coming out.
on the paper farms, that's how they do it.
Say again?
The paper farms, they take a certain acreage, and they have to figure out how many trees, and it lines up in like exactly.
And they know the idea that if they put too many, they're obviously going to use the nutrients and then get less yield, right?
Right, and
Okay.
they also have to take from certain areas, because it's going to take so many years to mature.
Gotcha.
So then they have to
Oh yeah, so there's more to the formula than what we do.
Same with
Always.
You're making
With-
barley,
Oh yeah.
same exact thing.
All right, that's a little more dear to some of our hearts, but the idea here is the more densely you put trees in, the less yield each tree is going to experience. So if each tree produces, where'd it go? 900 minus 9n apples. Say again? Still 3-1. Yeah. If each tree produces this many apples, how many apples are there total for that acre? How many trees are there? N. And each tree produces this many apples. So what's your total? They use the letter A, which I guess makes sense for apples. So each tree makes this many apples, and there are N trees, so there are this many apples total from that acre. Kind of makes sense. So the kind of problem that we attack with pre-calculus are problems that are normally called optimization problems. You want to figure out, what shape should I use to optimize my volume for some given surface area of material that I have to use, right? So obviously you'll see silos out in the real world. So some circular shape would be best, some cylindrical shape. This kind of question is, I want to figure out how many trees to plant per acre to optimize my yield, to get the most apples out, which makes sense. It's using the nutrients in that acre wisely. So hidden in here is quadratic. Of course, what I have to do to tease it out? Multiply it through, right? Now, please don't make the basic mistake of thinking A is 900 and B is -9. That's just the way it happens to be right now. We all know better. A is the coefficient of the squared piece. B is the coefficient of the variable by itself. Okay, I love this. So my vertex is normally x equals negative b over 2a. Our input variable is n. So let me just use n. What's b? 900 over twice negative 9. So we got 100 divided by 2 is 50. So I have to plant 50 trees per acre, and what it actually asks me for is how many trees should be planted per acre. Yeah. Now if it would have said how many apples can you expect once you plant the maximum number of trees you want to use. Yeah, just plug it in. Just plug a 50 in for n. What do you do, right? So the apples I get, if I follow this procedure, the number of apples I get will be whatever that is. All right. I'm tired. Which stands for somebody help me out. 22,500? Yeah? So I get 22,500 apples. So if I use anything other than 50, if I use 51 trees or 49 trees, you can kind of check yourself. If n was 51, what would I get? 51 times 900 minus, oh, you can do it, Jeff. 459. What's that if you multiply that out? What do you get? Somebody help me out. My brain is definitely too tired for that.
22,491.
Do it again.
22,491.
And this one got 22,500, so that's definitely more. That will be the max. And if you check out A49, it'll be equally on the other side of that. Because now you see the symmetry in the parabola. So this is obviously facing in what direction? So opening up or down? Down. Otherwise, if it was opening up, we'd somehow get infinite apple yield. That would be neat. Right? You want an apple? I got plenty. All right, cool. But I went through that semi-quickly, which is unfortunate. I should have went through it a little slower because you're going to see a lot of word problems like this. All you got to do is, and again, it's almost unfortunate that they set this up for you already. They have this formula staring you in the face. And then all you got to do then is put it in the right form, do the negative b over 2a thing, and then make sure you answer the question. Here they ask for the number of trees, so I can stop right there. If they would ask for the number of apples you can expect, you'd have to go a little further. That's the basic optimization pre-calculus word problem. In calculus, you'll have word problems. We cannot currently handle it if it's not quadratic. Because we know how to find a vertex of a parabola. We don't know how to handle finding all the little peaks in the middle. No. That's calculus helps us out there. Because calculus is the study of slopes. What's the slope at any peak? 0. So if calculus comes up with a really nice way to find the slope everywhere, I just got to find out where is it equal to 0. That could be a peak or a trough, and that's easy then. That's the beauty of calculus. We are certainly not there. So we're just going to see parabolas up or down. Here would be a minimum cost. Maybe this would be a maximum profit or apples. Okay. I can't remember. Did I? Somebody have their homework sheet right there? For 3-1. Did I sign it? Sorry. All right. If I don't get questions on number 76 out of 3-1, I might be a little concerned.
Yeah, 76 is ridiculous. Can you help us on that?
Yeah, sure.
I have a question mark. That's how far I got.
For which one?
I do the picture and I do a question
Oh,
mark.
for 76. So I'll tell you what, guys. If you have your book, this is good. But please open it up to page 231 and try out number 76. Just try to start setting it up. I will help you, but I want to let you try first. So You just hang out for a little while. You already tried.
Yeah. Otherwise known as exercise.
How am I supposed to even draw that? That's the fun part of this lesson. I got the f of x part down.
What was the problem you wanted us to do again?
Number 76, the rain gutter problem.
That is the one we were at. You know what? I know people that do rain gutters. They don't know.
Yes.
And all of them can do.
I doubt it. They could. They wouldn't be doing rain gutters.
We really did not design this. There's number 76 there.
Once you get
Guys, anybody trying that out? Or you're just kind of waiting.
I got f of x equals
Yeah, he's going to try it, so
try to wait.
I'll doodle something.
0.
If he looks at me up. That's what I would do, right? All right. We have a 30-inch wide rectangular metal sheet as shown in the figure. So it started off 30 inches. And the minute I fold it up, so I'll fold it in by X. So now looking this way at it, I've got, this is X, this is X. So how much is this?
30 minus 2x.
Cool. So they did supply a picture. They did label the picture, but they didn't fully label it. So there's still something you have to consider. This will be 30, what it used to be, minus 2x, because I've taken x and x away from each side. So minus 2x. It's that long now on that side. You guys with me?
Yes.
Okay. So now we're looking at the cross-sectional area. That's why some of you guys might think they didn't give me enough information. They tell me how long it is. Who cares? I just want to look at the cross-sectional area. I don't care how long that thing is. So what did I say? Find a function that models the cross-sectional area of the gutter in terms of x. So what would the area of this be now? Don't overthink it.
30 minus 2x.
Yeah, it's just going to be x times 30 minus 2x. Just a little rectangle now. Right? It'd be a lot more interesting if I made a trapezoidal shape or something. But they missed their chance. Sounds like something I want to do on a test. I was wrong, guys. You got to remember reverse psychology. Sure? Yeah.
We don't want to.
Now I'm so going to do it. It's going to happen.
You want it.
That's easy. So do you see how now we're at the same step we were over here? So no matter where the hell it comes from, they give me some situation, I write the function that we're curious about. I want to find, we're eventually going to try to find the maximum cross-sectional area, which makes sense. For some given amount of material, how do I make the area, the amount of stuff it can hold, a maximum? Which kind of makes sense. Now in the real world, you have to then worry about, well, is that possible load going to be too much for the material itself? So in the real world, every single formula we look at in here, in the real world, it's going to have several more variables attached. So you got to remember, we're always just learning the idealized situation in here. As you go further in your specialized areas, you're going to start to attach on more variables. Okay. So for right now, thankfully, it's just this business here. So no matter where the hell this came from, what's the steps to go from now? I've got my quadratic basically almost.
Turn it into the quadratic.
Yeah, this will be 30x minus 2x squared.
Vertex minus
And the vertex will be, what's b?
30.
30. Good. So negative b over twice negative 2. 15 halves, so 7.5. Cool. And what does that actually ask me? Find the value of x. Ooh, all right. 7.5 inches. And then what is the maximum cross-sectional area? So that's like I was telling you earlier. I just plug it back in. What did you do, right?
Is that the equation?
You can plug it back in the equation. You can plug it back in the picture. That's 7.5. That'll be 30 minus 2. That'll be 15. 15 times 7.5. You don't even have to use a function because you got the idea of area. Or just plug 7.5 back in here. Either way. How you guys doing? You guys doing okay?
My problem was more with the word cross-sectional than that.
I got you. All right. Yeah, they should have. They tried to show the whole thing, but they should have maybe, if they would have drawn this, obviously that would have given the whole thing away. But the fact that they don't tell you this length should have been like, did you forget that, or does it matter? Okay, cool. So I desperately try to get you guys to realize that at this level, you've got to start seeing the pattern. You've got to start seeing, no matter where the hell, whatever the situation was, the minute I get here, I can attack it. So then what's my goal, my motivation in this first part is trying to set this thing up. Somewhere there must be a quadratic coming out, somehow, somewhere, so I can then do this. Cool. Somehow. Any other questions from? Because I know there's a few guys have already started doing. Yeah.
The area for this is a rectangle.
Yeah.
The length is
112.5.
basically the height. The formula for the rectangle, the one you just plugged in. What was the formula?
Length times width.
Length.
Yep. Okay. Let's see, is there something else? No. Some of the problems, like number 51. Oh, sorry.
Just gonna ask that you mind what 44?
44. Oh, wait, that's right. That's when you were asking earlier. All right, guys, so I got a question number 44. Find a function whose graph is a parabola with vertex that, and then passes through the point that. I like that. Some little kid really hates math. All right. So what can I start out? What's the beautiful thing about it? What's the general shape? General shape. The general form then going to be? 44. 1.8.
A times
X
X. Yeah, plus 2.
Good. All right. So that's the general form. What do I already know? So I know the H. What's the H?
4 and 3.
What's the H? 3. How do I know that? Because that's the X piece. It goes with the X. What's the K? 4. All right. So how many variables do I not know that I need to know? No. 1. Because what do I want? I want a function at the end. So do I need to know the value of X? No. It's going to be whatever that wants to be. What's the one thing in my way that I don't know yet? The A. If you knew what A was, I'd have a function, I'd be done. Cool. So how in the world, what's the other piece of information they give me?
Where it passes through.
Yeah, now how do I use that? What must happen then? What's 1 and what's negative 8? What's 1? That would be
What is an X?
the input, that's the X value. So when X is 1, the output better be negative 8.
Uh-huh.
So that's telling me when X is 1, the output better be negative 8.
Uh-huh. You know,
So now I can just plug a 1 in
Yeah.
and a negative 8 output and solve for 8. Now, you get to a point where you get a collection of categories of problems. And this is a category of problem that shows up a lot. Find the equation of the hyperbola, whose focus is at this, and whose passes through the blah. And you start just, where can I put in what I know? What do I not know? What else do they tell me that I haven't used yet? I mean, that kind of problem is standard. But it's not standard for you guys yet. Right? So what do? You say, what do I know for damn sure? The 3, 4, I know that for sure. Let me just throw that in there now. Okay, this is where I am now. I don't know what the hell A is. What else do they tell me? How do I use what they told me? And of course, that goes to the basic idea of function. If I know the point it goes through, I know the input and the output for it. So now if I get the output's negative 8, when the input is 1, that's a beautiful little easy equation to solve.
How do you come up with like negative 8?
I didn't come up with it. They gave it to me. Right? If it goes through the point 1, negative 8, if any function goes through that point, that means f of 1 must be negative 8. That's period. If a function goes through a point, that means f at the input is the output. So now I can use that. When I plug a 1 in, I better get a negative 8 out, and now I can see what a must be to allow that to happen. There's only one value of a that can let that happen. If you can't solve that, I will cry a little bit.
Negative 1.
Right? Subtract the 4, negative 2 squared is 4, divide by 4. So what do you get?
Negative 1.
Minus 4, get negative 12 equals a times 4.
Oh, wait. Negative 3.
Negative 3. So now what's the function? So that's negative 3 times x minus, where'd it go? 3 squared plus 4. Don't make the mistake that algebra students make when they're solving an equation of a line. They get m and they get b and they forget to put it together. They forget to actually answer the question. Give me the function that does this. If you stop here, you didn't give me the function that does that. Okay, cool. Oh.
Yeah.
They give you these, which I just finished saying that we can't really work with these, but they actually give you just the graphs, so you can certainly estimate the local maxes and mins. We've talked about local maxes and mins before. I showed you how to do it in the calculator. Now this is sort of like somebody already graphed it for you. Like that very first one, 51, what's the local max? How many local maxes are there? Careful.
54?
One local max.
51 is 1.
Right, there's 2 local mins,
Yeah.
1 local max. The local max looks to be, careful, at 0, but the local max is 2.
2.
I love it. The mins look to be negative 1 and 0. You guys with me?
It's negative 2.
Can you have a min higher than a max?
No.
You want to try again?
Negative 1 and 0. Yeah, you can.
Wait, your minimum?
Yeah, negative.
A local min should certainly be higher than a local max, right?
Yeah. It is right there. And that one's there.
Not really doing
It can go.
it. Yeah, there's one right there.
Wait, local min.